The next classification of numbers are called rational numbers, which can be denoted using this symbol. And again, rational numbers encompass all of the other classification that we've mentioned so far, as well as decimals and fractions. However, the decimal numbers must be numbers that can be expressed as a fraction, where p and q are integers, and q is not 0. So, for example, 17 over 3 is equal to 5.666 repeating, and since the numerator and denominator are both integers, this is, in fact, considered a rational number. Now, whereas this looks fairly organized with its repeating sixes, even something like 19 over 17, which yields this rather unpredictable looking decimal, would still be considered a rational number. And why? Because this is an integer, and this is also an integer that is not equal to 0. Okay, so far so good. So if I told you that I'm thinking of a number and that it is a natural number, can you assume that this number is also a rational number? Well, definitely. You can also assume that it's a whole number since that's a bigger set. You can even assume that it's also an integer, since it's an even bigger set than that of a whole number. And finally, as we mentioned, you can also assume that it's a rational number, since rational numbers are a bigger set than the set of integers. We can compare it to something like this. If I said that there's a person in Tokyo, can we also assume that this person is in Japan? Well, obviously. As well, would we be correct to assume that this person is also in Asia? Absolutely, since Tokyo is in Japan and because Japan is in Asia. And finally, would it be okay to assume that this person is on Earth? Well, of course, because Earth is even bigger of a set than Asia. Good. Now, there's a whole different set of numbers that is not within any of these. This set of numbers cannot be expressed as a fraction. Another way to describe this is that this set is completely separate from the rational numbers altogether. Fittingly so, we can call these numbers irrational numbers. An example of an irrational number would be pi. And we know that pi is a never-ending number that does not repeat with a constant decimal or in a pattern fashion. And this is what makes it irrational. Square root of 2 also turns out to be an irrational number, since it cannot be expressed as a fraction. And lastly, the definition of real numbers is the last classification that we'll talk about. Although there are some other classifications that you might learn later on down the road. Real numbers are simply all of the rational and irrational numbers combined.